lucky that I have not.
والله الدكتور محمود هو اللي قال يخش.
هو ده الدكتور الشيرمان قاعد يقول الدكتور احمد انت مش موجود.
ما في بحسنا يعني. Anyway, this is I think the last presenter. The title of his presentation is Environmental Engineering Group and Water Quality Management Unit, Cairo, Egypt. This is the debate maybe. The paper titled Wind Field Design in a Highly Fractured Aquifer System, a case study with the Egyptian Saud. Again, I don't have any background for Ahmed yet. So just give us just background.
For the paper?
No, for yourself.
My name is Ahmed Zayed. I got my PhD in environmental biological treatment in cooperation with Bochum University, Germany. And my career was in the sanitation and environmental engineering laboratory. Cairo University. I was working as a consultant in Egypt for 15 years, and now I joined as environmental expert with the Ministry of Water, Jeddah region. بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد النبي الأمي الكريم. Ladies and gentlemen, distinguished guests, السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. أولم يرى الذين كفروا أن السماوات والأرض كانتا رتقا ففتقناهما وجعلنا من الماء كل شيء حي أفلا يؤمنون. Our presentation topic today is focused on the water resources management and titled under the address of well field design in a highly fractured aquifer system. And we have taken a case study of the Egypt Siwa Oasis, and this is in cooperation with the National Water Research Center related to the Ministry of Water Resources and Irrigation, Egypt. And the consultant for engineering, EMG, is presenting the financial and also the know-how transfer engineering office between the governmental clients and the case study. The contents of our presentation today, as shown in the slide now: introduction, materials and methodology, subtitled by description of the study area, and the model introduction from the data, and the results and discussion, and finally conclusion. We don't like to go in deep for the introduction, but just I like to focus that the main item of this case study is we developed a mathematical model, and it's called ANN, and it is a new technique for the empirical models which can be capable of identifying direct mapping between the inputs and the outputs. And this is called an abbreviation ANN, or abbreviated artificial neural network technique. Actually, this technique is widely scientific and have a lot of variables and very complex for the direct and indirect inputs criteria. Using the ANN technique with the computer, it will give you intelligent decision using, especially in Egypt, for decision makers whom are responsible about the water resources. And also, we see here in the model, in the next few slides, that the results is giving according to the underground aquifers and also for the water levels or dynamic water levels and the influence radius of this one. Computer is not If we go directly to the description of the area under the experimental methodologies, that we will see the Siwa oasis and the location map of the Siwa oasis we can see here in this map, which located near from the Libyan border in the west, near from the Mediterranean Sea, about 125 kilometers. And if you see here in the top slide view, the subdivision, the quality of the water of the springs, and down you will see here also spring for recreation in the Siwa oasis. And the topographical map, if you see here the location of the Siwa related to the Libyan border, and also near from the Qattara depression in the east. Actually, we have been recommended this technique to rehabilitate the existing wells which have been dug by so many farmers, and also the excessive consumptions of the water underground aquifer. And the field investigation which conducted by the Research Institute for Groundwater, we have taken as a reference or as a background to guide us to the exact proper locations and mapping of the what's calling the XYZ of the well itself. We can see here also that we reached the total water produced from both wells around 400,000 cubic meters daily. And also some springs for the existing system have small discharge or flow rate about 80 cubic meters per hour. Here you can see also the surrounding and scattered plotted wells were marked with the black dots that you see, and propagated over the plant area of the land there. And you will see here also that Siwa in this blue border identity territory, surrounded by the black dot screen lines. Let's go to the model indeed, which is the main objective of this study. That in order for explicitly and to focus on the relationships between the proper variables which can be taken into account for building a reliable model, can give us the three components of the objective of the study is the depth and water productivity described in flow rates, and also the distance between each two center lines of the wells to avoid interference between the two suction cones, to have the total global radius of influence for the underground aquifer of the Siwa oasis itself. The model of function of this model is defined by the network architectural, and we're taking the magnitudes of this in the matrices, and also we have taken adaptive theory of the latest advanced ANN model, or what's called the artificial neural networks. And through the learning of this work, we have been also responded to the correct environmental impacts surrounding the area. And then can we conclude the output of the node itself, which expressed in this formula y sub I, and you can see the output expressed in the factor of a sub I, and accommodating both nodes for the output and the input, you can function the total f function of x equal 1 over 1 of plus exponential to the minus x. Yes, please. Finally, we can conclude the root mean square, and in this formula, based on the AN technique or the advanced model technique, which can describe the summation of both of the t and y. So RMSE, based on the approach of the ANN, can result the formula shown for the total factors in the from n minus up to the total number of n. And also the validation set of taking the minimum value, you can see in the next slide, generating the rules based on the MARIN 1990. We can conclude also the error and the error calculation of the training sets of this summation. And the basic of the later equation in order to propagate the terms of the error, and we produced a similar going to the final results down here, which is the delta of WQ, and it can be expressed in the right side variables here in delta W. And we can go concluded, as we see in this last model down, that the error terms can be in connection according to the components of the weights of the variable itself participated in this factorial summation matrix. So finally, we can conclude, Chairman, as we committed to finalize within the 10 minutes limit. So the spatial distribution of the new wells which have been reconstructed and rearrangement in the seawall wells of the pattern around 66 wells, and also we reached the optimum peak discharge flow rate from the well from up to 360 cubic meter per hour. And we can see here the scattered and spatial distribution of these new wells based on the flow rates and the legend on the top east side or left side on the top. You can see here from 10 up to 360 cubic meter per hour, and the XY or the what's calling the location horizontally and vertically on the plan. And we can see also here based on this that the distance of each well in relation of the surrounding adjacent circumferential wells have not been interfered with each other. And we can see here this is the transformer frequency distribution based on the flow rate and the maximum flow rate that the frequency exceeds 22. The genetic algorithm used for developing this model, we have been also examining and making correlation for well producing based on this highly fractured aquifer, and we reach it to the bottom down formally for the root mean square equation, this one, RMSE, and we can see here expressed instead of W, the previous one, by O. And if we can fit this in polynomial model for the free water discharge, we can see here also that according to the horizontal projection in horizontally from 0 up to 3000, that this root mean square can be fitted, and the points within the curve itself it have been very close. It means that the results will have been correctly and of the correlation was fitted rightly. If you see here, this is the final O sub I, which is measured, and the P, the predicted output, and the number of wells. And we can reach also within the multiple that we can the index, because we have to reach to the index for the final evaluation of those arrangements, and we can see in the bottom of the slide the D or small d, which is the final description of the index of the arrangement or the artificial neural network. Going into such details like we have seen the difference and the values and measuring the intervals of those variables, we can conclude based on learning systems the approach for inducing models from data demonstrated the capacity of the artificial neural networks are very useful and reliable to determine the aquifer potential based on the flow rates of the highly fractured aquifer systems, such as our case study in Siwa Oasis. Computer processes this. Using the back propagation learning rule, the developed ANN technique model performance satisfactory for the flow rate special prediction of the 66 wells, the project over the area, as we have seen in the previous slide, and add the unsampled location index, which is expressed in the formally we have seen in the previous slide, that the index arrangement can be located in the range of 0.58 up to 0.79. For the free-flowing discharge from wells, the boards found a special correlation between the existing wells for a distance that we have to localize the wells at a differential distance between each other center lines, not less than 900 meters to avoid influence interference. And finally, this is the results which closely matches the pumping test which we have done for the productivity of the well's flow rates, and the reliable stagnant dynamic level matches with the cone of depression of the area itself, and provide the valuable information, and we provided to the decision makers in the Ministry of Water Resources to develop such a new area for water productivity in Siwa Oasis. Taking into consideration that the leachate from the northern Mediterranean Sea with the salinity of the underground cannot affect the area of the underground aquifer in this space of the highly fractured in Siwa Oasis. And we can consider this paper presented to you, gentlemen, is intended to assist those authorities involved in the design of groundwater well fields such as Saudi Arabia and the arid environments to take the decision maker with groundwater resource management in such complicated system. And thank you very much for your attention and for your valuable input. Thank you, sir.
Thank you very much for this excellent presentation. And now we can have questions from both sides here. And ladies, please, we'll start from here. Go ahead. شوف
Dr. Ahmed, you used genetic algorithm and sometimes we see your networks. I mean, why use genetic algorithm? I mean, how can, for example, there are another optimizations algorithm which is more easier and not complicated as genetic algorithm to do something like this? For example, when using this, especially optimization, you have to use two techniques, three of them, because you don't know the exact result. In this case, you have to use some like table search, like selecting and aiding, like local search, much easier than genetic algorithm. Use genetic algorithm for very complicated problems with manipulations.
Yes, you are absolutely right for the outframe of the decision taking for the model itself, or what is expressed in your valuable comments, the genetic algorithm. But as we have seen this slide, which can representing the response of your query, in order to produce this successful predictions with the minimum amount of error and training time also, and also for the optimization technology, we used such type of genetic algorithm, which have been used before in previous case study and was successful. I know it is you can say not complicated or a complex algorithm, but it is more sophisticated. Yeah, it needs just concern and just time to focus on the variables itself and to select the inputs and output, and also the subset of the data from provided configuration, and raised also in the artificial neural network, as have been in the introduction, will give the exact various or variation of the parameters, and we can include the proper control of the ENN technique. And down we can see also this one can result on the RSMA. And thank you for your valuable question.
From the side, do you have questions? I think the left. You get, by the way, for the presenter, because I have just to confirm the attending. So this is why we get confused. Any more questions from our side?
اخش قبلها بنص ساعه. فاحد الاخوان جامعه الملك فيصل الدكتور محمودي فقال لي على فكره في ناس ما جاتش، نخش بسرعه. دخلت صح بكره. والله هو في نشرب شاي مع الدكتور كوبار.
لو خرجت مش هنرجع.
احنا محظوظين يعني.
بالعكس
الله يبارك.
طبعا احنا في البلاد العربيه نحتاج الى وقت عشان
نخش.
بس لا يعني it's coming يعني بس اهم شيء لان الظروف كلها
والله انا مرزوق ما شاء الله يعني. نشوف فيها ابلكيشن بيبر التصنيف العالمي اللي هو ضمن جامعه عربيه وحيده كلاسيفايد ضمن اللي هو جامعه على مستوى عالمي. فخر ليكم يعني.
احنا يعني مدير جامعه لا يفرق بين الناس واعلنها نظاما
اللي هو الدكتور
جل الزمان يعني اعلن عن البقاء للاصلح. فهذه فرصتكم يعني.
وبعدين ما شاء الله تحت معنا اخوه عرب كتير جزاهم الله شاكرين.
لا تنسوا عمرها يعني.
محاضرة كويسة جدا.
جميل وديع. الحين في صار كذا.
يجوز تأشيرات الحين في الآن.
لا فاين هي في كان مستر ديفيد عامل ورقه في جورنال وكذا هي نفس هذه الكونديشن بنعمل بابليكيشن في انترناشونال جورنال
كريم الصين
You remember when you made this law?
I couldn't find it in the
I didn't give it to you.
I couldn't meet an inside.
You are fond of copying the.
I wanted to find the logo. If I remember, I requested to.
You are from Pakistan, right?
Yes, yes.
Yes. يدينا صورة دكتور محمود.
ماشي. أكثر صورة.
دكتور يدينا صورة. شفتوا عملت برزنتيشن؟
No.